So an air mass is a big chunk of air. I guess how big? As big as maybe 3 or 4 states, kind of Midwestern states. Okay, so that's a pretty big chunk of air. And what the air mass is got very similar conditions throughout, and it has similar conditions throughout, and it's on the next slide just because it kind of sat somewhere for a long time. Okay, it sat over what we call a source region. But air mass has uniform conditions, kind of what we say, at least horizontal. It's not to say, you know, like if it's all warm, it's all going to be warm down here. Now, within the air mass, as you go up vertically, it's going to change, okay, but it's all warm, kind of at least in layers, or cold. Now, so a front is actually, we've been talking about fronts in here. You guys know a cold front, a warm front. So a front is where you have 2 air masses that are butting up against each other. Okay, and actually, Chapter 9, we'll talk more about fronts. So how do you get an air mass? How do you get something that's the size of several states to have the same temperature and or moisture? And you let it set over what's called a source region. Okay, so a source region, and I'll kind of show you a map of North America and show you where do these chunks of air sit to pick up the characteristics of the region. They sit for maybe 2 weeks or so, they kind of simmer, and then they move on. Okay, it makes sense, I think. So, yeah. I've heard it described as kind of like an accent, and maybe this is what your textbook talks about. It's like if you go visit someplace, you pick up kind of an accent of that region, source region. So the 2 things we're going to talk about specifically are temperature and moisture. Temperature and moisture. Those are the things we're most concerned about with regard to an air mass. Okay, now there are other things, atmospheric pressure too. Okay, now if you don't mind, in your notes where it talks about entire air mass can vary vertically, entire air mass can be either stable or unstable. If you don't mind in your notes, so I don't forget, actually where it says stable, go ahead and say cold and dry. Cold/dry tends to be an air mass that's stable. And of course, the opposite of that would be unstable. So an air mass that may generally be unstable is one that's warm and wet or moist, whatever word you want to use.
Warm and wet works, 2 W's.
That works, two W's, warm and wet, unstable. I like it. Okay. So it's a little bit like the clouds we talked about, where clouds you kind of mix and match the elevation with kind of flat or fluffy. So the 2 things we're mixing and matching here, like I said, are temperature and moisture content. So temperature, we have 3 options. Okay. We have temperature could be warm. We only have 1 warm temperature, and we have 2 options for cold. We have cold or we have very cold. Okay. So start to kind of get in your mind that capital T is for warm. Capital T stands for tropical. It's for a warm air mass. A capital P stands for polar. It's cold, but not as cold as the other one. And a capital A is Arctic. Okay, so then the other thing we need to describe our air mass is the moisture content. And we talked about, goodness, back in Unit 1, we talked about you could live on the coast, okay? And if you live on the coast, we call that a maritime location. And so actually we're going to fall back to maritime. And you could think of lowercase m, it really means maritime, but it could also mean moist, okay? So if your chunk of air is moist, you're going to have the little letter m next to it. If your chunk of air is dry, then we're going to say, actually, its source region was land, and the largest land we have is a continent. So if it's dry, we call that a continental. So it's going to be lowercase c. So with all that in mind, we end up with 5 types of air masses. And here they are. And there's actually a 6th possibility, but we'll kind of talk about why that doesn't work. Okay? So they're listed, let's see, how are they listed? They're listed by these, we have Continental Tropical. So hopefully when I say Continental Tropical, lowercase c, uppercase T, you're thinking Continental Dry and Tropical Warm. Continental Polar, Dry, Cold. Maritime Tropical, Moist, Warm. Maritime Polar, Moist, Cold. Continental Arctic, Dry, Bitterly Cold. So, you know, it's a little fuzzy sometimes knowing where one air mass stops and another air mass starts. But keep in mind, as I've kind of, my hands represent 2 air masses, what's between the 2 air masses? Starts with letter F?
Front.
A front, exactly. So there's a front between the 2 air masses, so kind of keep that in mind. So this is just a, I'm not sure what you need to fill in here. It's a figure from textbook. So 5 types of air masses. Anybody see which ones may be missing?
Stationary?
No, a type of air mass. That's a type of front.
Yeah.
What about what about another Arctic? What would the other Arctic? Maritime Arctic, exactly. It's like, to be kind of fully complete the picture, it seems like we should have a Maritime Arctic too.
Could go on top.
Why wouldn't there be a Maritime Arctic? What happens with bitterly cold air?
Sinks.
It sinks. Very cold air. What about moisture in very cold air?
Very low.
Very low, that's right.
Maritime, that usually means like,
There's moisture.
and then
Yeah.
you say maritime polar, then there's a lot of moisture in the ocean, and that kind of contradicts itself.
Well, maritime polar works okay because it's not bitterly cold. But I think I heard y'all say that if it's Arctic, it's very cold. The thing is that it doesn't hold much water. Very cold, holds very little water. Very little water. Yep. Very good. I think that's one of your homework questions. Okay. So, I've got 2 maps here from your textbook that show the source regions for these 5 different air masses. Okay, this one is in the winter. Okay, so let's just take a look at what those source regions, so you kind of see the blobs, you see the arrows, so they sit there for a couple weeks and then they move according to the arrows, okay? So for instance, if it is continental Arctic, very cold, bitterly cold and dry, they're going to be up over Canada / Greenland, okay? That's our source region for those air masses in the winter. Continental Polar, not as cold as Arctic. Then we kind of have in kind of more central Canada. We have 2 source regions for Maritime Polar in the wintertime. Of course, one in the west, which is the North Pacific, and one in the east, which is our North Atlantic. So Maritime Polar air masses would be moist and cold. Then we have these 2, what are these going to be down here? Continent, are they're maritime, are they warm?
Yes.
Yep. These are our sources for maritime tropical air masses in the wintertime. I'm going to go ahead and circle continental Arctic up here, because this actually is only in the winter. In the summer months, there's no source region for that. You can't get bitterly cold air masses to form up there. There's no source region. All right, so that's the winter. And then the summer looks very similar. But like I said, the summer now, you'll notice we don't have a continental Arctic, but we have continental polar. And the summer is very similar. Kind of we have the flanking maritime polar on both oceans. Okay, and then we have, kind of coming up from the south, we have our Maritime Tropical sources. But now in the summer, we pick up another source region, Continental Tropical, right there. So actually, I'm going to circle that last one, Continental Tropical. I'm going to say only in summer. In the winter months, we don't have a source region for Continental Tropical air. All right. So, you know, like I said, it was like when a chunk of air sits over a source region and picks up the characteristics of that region it's sitting over, it's like gaining an accent. Well, you can also lose an accent. Okay, and that's kind of like what air mass modification is. I bet it makes sense, and we're going to see an example. If you have a chunk of air, for instance, that's continental polar, so it's like over Canada, it's dry and it's cold. Well, it sits there for a while, becomes that air mass, and then it goes south. Okay, it's going to get warmer as it goes south, and that's called air mass modification. Basically, kind of right at the interface of the land and the air mass, you know, it's going to exchange heat and moisture. So, oops, I should put that there. Air mass modification. That kind of makes sense. It's losing its accent. And our bird is still going. Hobby Lobby, $10. Okay, so this is the figure I was telling you about where air mass modification is occurring. You definitely have a continental, I don't know, I guess you'd call it continental polar air mass, and it got very cold and dry, and then it started to move down. And you can see its original temperature in Fahrenheit was -51. Oh my gosh. And then it's -27, -20, -9, so it's getting warmer and warmer as it goes down. Okay, so it's becoming modified. Here's another one, kind of related to that. If you have a chunk of air mass and it moves into your area, it brings with it the weather. That it's like it could bring warm weather. Okay, there's this thing called just air mass weather, and that's sometimes just the big old blob. What are you experiencing? Well, I'm experiencing whatever my air mass brought. Okay, air mass weather. And actually, when we talk about weather forecasting in Unit 4, one way to forecast what the weather's going to do is basically say, well, whatever it is today, it's going to be tomorrow. And there's some locations in the world that actually can do that pretty well. It's called persistence forecasting. So I'm not going to go through all of these. It's a figure from your textbook that again looks at those 5 different air masses and looks at their source regions. Notice a little bit, I don't know if you'll find this helpful, you may or may not. One of these columns talks about the stability. And then I kind of have some few slides on talking about the air masses, a few of the details. But continental polar air masses, you figure it's dry and cold, and it can bring some things with it. Do you remember a few slides ago I said for stable, I said go ahead and put dry and cold. So continental polar air masses are really pretty darn stable. And we talked about stability and instability the other day, or in the previous unit. So stable means it's not going to want to rise. One of the things about air that doesn't want to rise, and it's up here, is that this sort of air mass, if you have any sort of emissions going on in your city, like pollution, basically it's going to, this sort of air mass can kind of make pollution an issue. Okay, lake effect snow. You're like, what does lake effect snow have to do with anything? Well, actually, lake effect snow is a good one to kind of talk about air mass modification a little bit. You probably are kind of familiar with lake effect snow. Look at the Great Lakes, and basically kind of downwind from the Great Lakes is where they get dumped on. Okay? So what happens, or what can happen in, especially, I would say in the fall, as we're kind of transitioning, or in the winter, but you're going to see a picture here in a minute. You can have a cold and dry, So that means polar, continental polar air mass, basically move over the Great Lakes. If the Great Lakes are kind of warm, they basically kind of add moisture to that cold and otherwise dry air mass. It becomes changed, and then on it dumps on the other side of the Great Lake. So here we go. So kind of from left to right, we talked about kind of this prevailing wind. Okay, remember the Great Lakes would be part of the Ferrell cell, so they do have a surface kind of mid-latitude westerly wind. So you can have a continental polar air mass, cold and dry, going over the Great Lakes. Notice the Great Lake is, in this case, a little bit toasty. Those large bodies of water take a while to cool down. So if it's toasty, then one of the things we know is that it's going to be perhaps kind of, those little squiggle marks are evaporating water, okay, relatively moist conditions. So you can see the clouds forming there. So basically what was dry is picking up moisture. And then on the other side, with a little bit of friction, you can actually kind of get a little bit of lifting mechanism going on there, and it can go ahead and dump its precipitation on the other side. So your textbook has a map showing you snowfall to kind of show you this lake effect snow. So let's see if we can find lake effect snows on the downwind side of these Great Lakes. So I'm kind of liking this. Okay, Buffalo. Oh, they always complain in Buffalo. They do get hammered, don't they? Okay, that's lake effect snow. Here's another example where the air becomes modified. Again, the type of air becoming modified, and it's kind of similar to lake effect snow. But now instead of a lake, we have the ocean. This is the Atlantic Ocean. We have dry, cold air blowing into the Atlantic Ocean, catching a ride from the mid-latitude westerlies, and it picks up moisture out here, and kind of like we saw with lake effect snow, it picks up moisture and goes ahead and forms at least clouds, shown here. All right. So continental Arctic air masses. Continental Arctic. Oh my gosh. So Arctic means very cold, right? Yeah. Polar means cold. Arctic means very cold. So there's this thing called the Arctic front, or unarctic front, I guess I should say. It's not always there. And it's between two dry air masses, one bitterly cold Arctic and one just kind of cold polar. Okay? So there's this figure, and I don't think it's in this edition of your textbook, but hopefully we'd be okay. How do I want to do this? Let's see, this is the North Pole. Oh, 90 degrees, North Pole. And then this would be going south towards the equator. So, of course, this is, A is bitterly cold, and P is just cold. Okay? So kind of that line right there would be what we call an Arctic front. That is an Arctic front. But I want to go ahead and differentiate it just a little bit from something else we've talked about, which is the polar front. So in the previous unit, we talked about a polar cell, the Ferrell cell, and of course down here we'd have, I'll go ahead and put H for Hadley cell. Okay, so we said that between the Ferrell and the polar cell in both hemispheres is the polar front, and this slide tries to kind of show you that the polar front is much crazier, cooler, always there, awesomely big, and this Arctic front may or may not be there. It's just between those two types of air masses. So I'm kind of put that into perspective. All right. Maritime polar. Maritime polar. Maritime meaning moist or wet. Polar meaning cold, but not bitterly cold. We talked about two source regions in both seasons, kind of coming from our North Pacific and North Atlantic. Maritime polar air masses. So the fact that they bring moisture means that they can bring precipitation with them. In Chapter 9, on Monday, we'll be talking about these big weather systems called mid-latitude cyclones. And so actually mid-latitude cyclones count on that moist, cold air to kind of move in North America. All right. So NorEaster, actually it's a type of mid-latitude cyclone, and it is formed, you think of them on kind of our northeast, okay? And that, at the crux of a nor'easter is that moist, cold air, the maritime polar air. Okay, so a little more about air mass modification. So each one of these circles is an air mass. Actually, it's the same air mass. And again, this must be, looks like it's in the Ferrel cell with a prevailing wind, easterly wind, okay? So it can start out cold and dry. Hope that kind of makes sense. It looks like it's over kind of Eurasia, kind of. Okay, cold and dry. When it moves over the Pacific Ocean, it picks up, oh, it's still cold and dry there, Continental Polar, okay? But notice it's picking up some moisture, it's less dry. Any chunk of air that has a bit of moisture has a degree of instability, so it's becoming somewhat unstable. And then here finally with this third one, we show it actually modified from a continental polar now to a maritime polar air mass. Okay, so
Go back to
that's,
the previous slide for a second.
I can. This one?
Yeah.
Okay, maritime tropical, maritime tropical. So maritime meaning moist, tropical meaning warm. So we talked about a couple of source regions. These would be for us from the south, over either the Gulf or the two oceans. And these are unstable because they're both warm and moist. So these are definitely a player when we get hammered with precipitation. Just keep going. Maritime tropical. So maritime tropical air can bring precipitation, actually can bring severe weather. This is just showing you kind of some cumulus clouds, maybe going to develop vertically into and give rain to form cumulonimbus clouds. From this source region was the Gulf of Mexico. Okay. So, and I think this might be a homework question, but like on the, you guys told me in the homework that you handed in that basically the west coasts of continents tend to have this cold water going on, like California is a lot colder water than Atlantic. The other thing is that, and that happens with all continents on the west, on the east side of continents, basically, and I think we ran into this like the last slide in Chapter 7, the east side of continents get hammered with precipitation, just kind of how those, the ocean basins go clockwise. So actually definitely see that here. Maritime tropical air, bringing precipitation. So I added this slide this semester. This one's kind of new to me, but the Pineapple Express, somewhere in there, hopefully you can find maybe Hawaii. This is our, I don't know, Hawaii seems to be here-ish, but I don't know. But the Pineapple Express refers to, like this slide says, maritime tropical air moving in from that direction. And then this is kind of a review topic. We talked about monsoons. By definition, a pair of monsoon seasons are brought to a location seasonally because the winds change seasonally. So the winds change seasonally. It brings a warm, wet season and a dry, cold season. And so we talked about the monsoon season here in our southwest. And part of the crux of why we get all of that rain here, okay, so these are, and I think these are in inches of rain, which is, I guess, too bad. Anyway, July, August, September, okay, is we have, remember we have a low pressure there. We talked about this monsoon, seems like just the other day. I'll put an L there for Arizona. We have a low pressure here because it heats up more quickly than the ocean. And then we have, that creates kind of an incoming sort of situation. And now since we've talked about air masses, we get that from our South Pacific, basically, the maritime tropical air moving in and dumping. All right. So, continental tropical, continental meaning dry, tropical meaning warm. So remember we said that this is the air mass that we only get in the summertime, continental tropical. Yep. And we'll talk more about this, I think, in the next chapter when we talk about fronts. But when, in the summertime, when that dry, warm air clashes with warm, moist air, okay, so they're both warm, so they're both tropical. So we have continental tropical and maritime tropical. When they clash, we call that a dry line because they're both warm, but they just differ by moisture. And if you are a tornado chaser or you're hiring somebody to help you find tornadoes, actually when these start to form in the springtime, a dry line in our southwest, that's when conditions might be favorable for tornadoes. Severe weather, yeah. I'm not saying anybody should go chase them or anything. But is that it? Score. Okay, well, that's all I got for today. Oh, wait, so do you guys want to look at the homework right quick? Okay?
Yes.
Okay. So, chapter 8. PHS165 chapter 8. There it is. Okay. So here we go. So does this one have an asterisk? I don't have my thing. Does the number 2?
It's right here. Chapter 8 does number 2?
Yeah.
No, it just has.
Okay, so complete sentences for, I guess, these two. So for the first one, it says, we talked about air mass, we talked about source regions, and it goes ahead and it reminds you that source regions need to be relatively the same throughout. That's homogeneous, okay? And so it says, oh my gosh, it looks like between these two, the old mountain range and the newer mountain range, it seems like we have a prime spot right here for a source region, but there was no source region really there. We had one here, continental tropical in the summer, but we kind of had them here and here and here and then here and here and here. And so you're supposed to say, why would that not be a good source region? Go. So why don't you think that would be a very good source region? Anybody?
In between two mountains.
It's in between two mountains, actually, and it's pinned between two mountains. I would buy that. I think it's pinned down.
Not as much moisture.
Pinned down. Well, it could be a dry one. I think it's pinned down. The other thing, it's pinned down, and I think I've read it's a little too busy there. By busy, I mean we have a lot of cyclones and anticyclones kind of go throughout the area. Those other regions are kind of more quiet. Okay, the feral cell is kind of more busy. So I would put pinned down by mountain ranges, because then even if it did go ahead and become whatever temperature and moisture, it's not going to necessarily move.
Yeah, there's nowhere to go.
Yeah,
Yeah.
but the other is it's just kind of a busy, kind of a chaotic area. I think both of those. So number 3, what is the proper classification for, and we kind of talked about this. It basically says if you have something over the ocean, but it's a cold ocean, the Arctic Ocean. So if it's over the ocean, you're probably going to put M, okay? And if it's very cold, you're going to put A for Arctic, okay? And do you remember why I said we don't have that 6th designation? Maritime Arctic. Because cold air does not hold moisture like that, much moisture, yep.
So
Right. See, to me, it says, how would you classify it? You can do it either way, but I really think it should be just simply a continental Arctic because it's going to be dry even though it was over the ocean. I'll just say cold air can't hold much moisture. That's what I think. That's what I think. Okay, now the next one. Let's see. Now this one I probably said for number one, I probably said just kind of describe where the line goes, something like that. So in here somewhere, in this mess, you're supposed to look for 2 air masses. Okay, so there's 2 well-developed air masses. So you're looking for temperature and moisture. And I'm just going to kind of, what do you guys think?
Looks like there's a cold air mass in the Pacific Northwest area, kind of sinking down from kind of Montana.
And where does it break?
Actually, it almost sinks down through the upper tier of the Midwest through the Northwest.
Like this?
Yeah,
And what are you basing that on?
temperatures
Yep.
and the dew point too.
And what's the dew point tell you?
How dry it is.
How dry it is.
The real-
Perfect.
Not exactly.
I'm kind of
right.
trying to I'm kind of liking maybe that. Or maybe it goes like over here. Like I've seen the 53, 54. Oh my gosh, look at that. 33, 54. Maybe something like that-ish. So remember the top number is the current temperature and the other number is the dew point temperature. So for instance, while we're on this, let's just pick on this location in, is that Indiana? Okay. So 55, 54. The current temperature is 55, the dew point temperature is 54. Is that very humid?
Probably some fog developing on that.
I'd say I'd say humid, meaning let's go over to pick on, well, I see a good example here. What about, how about this one here? What state is that? This one right here.
Wyoming.
Thank you, in Wyoming. Okay, so 14 and 9. So what do you think? Seems like 5 degrees. You think it's dry? How many people think it's dry? Pretty dry.
It's fairly dry.
Yeah, I
But
think it's fairly
given
dry.
the temperature, there's a lot of moisture in there.
Yeah. It has to go, though, 5 degrees to go ahead and for condensation to
Yeah.
begin. So I'd say it's relatively dry. I don't know. Something like that.
It could maybe snow.
Okay. So so I guess we're all doing this homework together. So what would you call this one up here? What would you call that air mass? Would you call it, we said dry, so what do we call it, C or M?
C.
A C, yep. And does it seem cold or warm? Seems cold? So I'm probably going to put a P. I'm probably not going to put Arctic. What about over here? This one that's humid. So we put a C or an M? We put an M, yep. What do you think about temperatures? What letter would we put there for that one?
T for tropical.
I'm liking capital T for tropical too. Group homework.
So do we just have to redraw this for our homework?
I think my instructions said just describe it. If you want to draw, you can describe where the line goes, or you might take your hand at drawing it, or copying it.
Did we do number 5? Or give it some thought? Did we skip that?
Yeah, we did.
Well, let's see if it's over here.
What's the 55 and 54 state?
55
The one
and
where we
54
said
state.
Indiana?
You're asking me? This one down here? That's
No,
The
the
one
one
we
we
already
circled.
did.
The 55 circled in green.
And the green one.
that's Indiana. Because it's Illinois, Indiana. Then what comes over here? What's this one? I'm terrible at my states. Okay, and so you said 5? Well, let's just see. Let's finish this thought. And let's go back and pick up 5. So for this one, It basically says, you probably recognize these are the lake effect snow, right? Lake effect snow, lake effect snow, lake effect snow. And then what this question says is, what the heck is that? It's not lake effect snow, because it's too far from the lakes.
It's mountain region.
I'm thinking mountain region, yep.
And there's actually a kind of a rainforest in North Carolina somewhat.
Yeah, I think the mountains would probably, something about mountains in your answer would do it.
What?
Mountains provide the uplifting, and mountains can also pin down air. So I did miss one.
Number 5.
Direct. Well, let's look at who has their book. We're gonna have to wing this one. Number 5 says or asks, and does it give it some thought?
Oh, it's up here.
Yeah, okay. In each of these situations, oh, I thought it was there. In each of these situations, describe if the air is becoming more stable or more unstable. So my hint there is kind of what I said before. So remember I said stable, what conditions did I tell you to put?
Cool and dry.
Cool and dry, exactly. Cool and dry. Perfect. What about unstable?
Warm and wet.
Warm and wet. And so, you know, just do your best. And I think, is that one you don't have to use complete sentences, I believe, with an asterisk?
There's no S.
There's no asterisks? You don't have to use complete sentences for that one.
Yay.
Because it just seems like you should be able to say becoming stable, becoming unstable. Okay, so that's it? Yeah, that's it.
Okay, now